Okay, and number one, you're trying to write the name for this compound is LiF. So on the periodic table, you find lithium over here, and then F is for fluorine, but you change the name from fluorine to fluoride. So this is lithium fluoride, Fluoride, and the fluoride comes from fluorine. So that one's a simple ionic compound. You can tell because there's only one atom that's the cation and one atom that's the anion. There is no polyatomic nature to it, and it's not a transition metal. Okay, this one, K2SO4. There are three different elements, so you know there must be a polyatomic ion. And this SO4 you'll find is sulfate. So SO4 right here with a charge of 2- is called sulfate. So you have K, which on the periodic table is potassium. Right here, K is potassium. So it's potassium, and then SO4 is sulfate. Okay, CuOH. There are three different elements, because there's three capital letters. There's copper, and then the hydroxide. Now, the element copper has two different forms, Cu plus and Cu2 plus. And then the OH, that's a polyatomic anion, and that's right here, hydroxide, OH minus. So you need to figure out, is this copper 1 or is it copper 2? Well, you have copper, and then there's the hydroxide. Hydroxide always has a charge of 1-, and in the equation, there's one hydroxide and one copper. So this copper must have a charge of 1+. It's just copper 1 hydroxide. Copper 1 hydroxide. If it were copper 2 hydroxide, copper with a charge of 2+ and OH with a charge of minus, there would have to be two hydroxides to go with every copper. So the formula would be CuOH2. This would be copper 2 hydroxide. So the names are different, and the formulas end up to be different because copper 2 would have a charge of 2. You need two hydroxides to go with it. Okay, Agcl. So silver is a transition metal, but it has only one common form, charge of 1+, and Cl is chlorine, right over here. So the anion is chloride, so it's just silver chloride. Okay, BaCl2. Ba is barium, and barium has a charge of 2+, and chlorine has a charge of 1-. That's a simple one. It's just barium chloride. Okay, NH4,2S. This is a polyatomic cation, and it's up here. Ammonium has a charge of 1+. So this was NH4, 1+, and I can tell that this sulfur must have had a charge of 2, S2-. And if you look on the periodic table, you'll find sulfide is in the chalcogens group. It's 2 columns over from the noble gases, so sulfur has a charge of 2-, and because it's just a single element as an ion, we just change the name to sulfide. But NH4, 1- is ammonium, and then sulfur as an anion is sulfide. This is not to be confused with ammonia. Ammonia is just NH3 as a compound by itself. NH4 is ammonium sulfide. That name comes directly from the cation part of the ion chart. Okay, so those are good names. Lithium fluoride, potassium sulfate, copper 1 hydroxide, silver chloride, barium chloride, and ammonium sulfide. Okay, then to writing equations. So a number of these have transition metals, and the number that's in Roman numerals inside the parenthesis after the element tells you what the charge is. So lead 2 is Pb 2+. Lead as an element is Pb. It's right here, and there's lead 2 and lead 4, and lead 2 is the form that we want, And chloride comes from chlorine, and chlorine is a halogen, and it has a charge of 1 minus. So lead with a charge of 2 and chlorine with a charge of 1. You're going to need 2 chlorines to go with every lead, so the formula is PbCl2. Okay, copper 2 fluoride. There are also 2 different forms of copper, copper 1 and copper 2, that are common. So you have copper with a charge of 2 plus, and fluoride comes from fluorine. Fluorine is at the top of the halogens, so it has a charge of 1 minus. So you have copper with a charge of 2, fluorine with a charge of 1 minus. It's the same ratio as lead chloride, which is CuF2. Okay, calcium oxide. Calcium is an alkali earth metal. It's Ca with a charge of 2 plus, and oxide is the ion of oxygen. So we have calcium with a charge of 2 and oxygen with a charge of 2. So you have calcium 2 plus and oxygen 2 minus. And with the cross-down method, you might think it's Ca2O2, except you need a neutral compound, and because they have the same charge, you only need one of each. So it's just CaO. Okay, copper 2 nitrate. So this was copper 2 fluoride. We have another copper 2, Cu2 plus, and nitrate comes from not nitrogen, because if it were nitrogen as an ion, it'd be nitride. Nitrate is right here. That's NO3 with a charge of 1 minus. Nitrate is NO3 with a charge of 1 minus. So be careful that that's not nitrite, which is NO2 with a charge of 1 minus, but nitrate, NO3. So you have copper with a charge of 2, nitrate with a charge of 1. You're going to need 2 nitrates for every copper, but because this is a polyatomic ion, it's got to go inside parentheses. So NO3, 2. Okay, iron 3 sulfate. There are 2 common forms of iron, iron 2 and iron 3. This is iron 3, and sulfate is not from the element sulfur. That'd be sulfide if it were, as a sulfur ion. Instead, sulfate is on this ion chart, and sulfate, we used that before, is SO4 2 minus. So you have SO4 2 minus. Using that cross-down method, you need 2 irons and 3 sulfates, so it's Fe2 SO4 3 outside of parentheses. Because you need 3 of the sulfates, the sulfate has to go in parentheses with a 3 outside of it. Okay, magnesium nitrate. Magnesium is right here. It's a alkali earth metal. It has a charge of 2 plus. So we have Mg with a charge of 2 plus. And nitrate is not from the nitrogen ion. That would be nitride if it were. Instead, nitrate, again, is right here. That's NO3 minus. So you have NO3, 1 minus. You need 2 nitrates to go with every 1 magnesium. The formula is MgNO3, 2. And then cobalt 2 nitrate. So nitrate, once again, cobalt 2 is CO 2 plus, and the nitrate NO3 1 minus, it's CO NO3 2. So that's it for that